Congratulations on completing the first week of the course. We're going to continue right where you left off, and we'll start diving into memory models and scope. Again, this may be a review for some of you. If you feel like it's too much to review, feel free to skip ahead to the graded quiz at the end of scope. After completing scope, you can get started with the programming project, and you'll build your first application in unfolding maps. The programming assignment for the first course module is really aimed at just getting us up to speed and running with unfolding maps. I know that many of you are eager to get programming, but before we can get there, you're going to have to get unfolding maps set up and running in Eclipse first. So please follow through our text and our video guides to help set up unfolding maps for your system, and then turn to the forums if you run into problems. But before we get there, what I want to show you is an example of a finished programming assignment for this first module. We'll give you the code to create the map on the left, which is centered on us here at UC San Diego. Specifically, we're really right about here. Notice that on this map, I'm able to zoom in and out. So zoomed out, I'm able to zoom in, I'm able to zoom in towards UC San Diego, and we're really right over here. Now, being able to zoom like this is pretty amazing. A lot of work goes into making something like that happen, including getting the map data from Google Maps to the handling of my mouse scrolling in and out. These amazing features are really just part of the libraries and unfolding maps and processing, which is why we're using these libraries for this project. All right, back to our assignment. We're going to give you the code to produce that image on the left, which is our map on the left, which is zoomed in to San Diego. What we want you to do is create the map on the right, which we zoomed in to where you live. Now, I live in San Diego these days, but I grew up in Pullman, Washington, which is on the east side of Washington State, and Washington State's on the west coast of the United States. So this is really just a small programming assignment just to get started with unfolding maps. The big step is really just getting unfolding maps and working on your system. So select the right video guide for installing unfolding maps, Java, and Eclipse on your personal system, and I'll see you again for the assignment walkthrough.
In this video, we're going to show you how to get the starter code for the project and get it set up in Eclipse. So you've probably already found this setup document, which is in week 1, getting started with the project. It's talking about how to set up Java Eclipse and the starter code. And I'm going to assume that you've completed part 1, which is to set up Eclipse and Java. And we're going to jump down to part 2. So about halfway down the document, this is the part that we'll be going over, getting and setting up the starter code. So you can download the starter code from this link here. And what you want to do is download it and unzip it somewhere on your system. And the only restriction is we want you to put it somewhere that is not inside your Eclipse workspace folder. So once you've downloaded and unzipped the code, you'll go over here into Eclipse, and you should see a blank workspace if you haven't done any other coding yet in Eclipse. So what you'll want to do is to get the starter code set up, you go to the File menu, and then in the File menu, you'll click Import, and that'll open up a new window. And what we want to do is we want to import an existing project into our workspace. So that's under General. So I expand the General tab if it's not open already. Then I'm going to click on Existing Projects into Workspace, click Next. And then what I have to do is tell Eclipse where to find the code that I want to import. So I go over here and I browse, and I'm going to browse back to where I saved and unzipped that starter code. And I just put it on my desktop. So I'll go up here and find my desktop, and here it is down here at the bottom. So I select the UCSD Unfolding Maps directory, and then I click OK. And you can see that it imported this project, or it gave me the option to import this project in this window here. So the only other really important thing that you need to do is make sure that this Copy Projects into Workspace option is selected. We actually want to copy the files, the source code, and everything else from wherever we saved it into our Workspace directory. So just make sure that's checked. And then you click Finish. And then what you're going to see is that our code and everything else has been successfully imported into our workspace. So you can see that now I have this starter code. If I expand it out, you can see that there's a whole bunch of files associated with this project. And if I open up the source code, I can see that it's divided into these organizational modules, basically called packages. So there's one package for every module that has a programming assignment. So module 1, 3, 4, 5, and 6. And that's where you'll find the starter code. So here we can see the starter code for module 1 in a file called helloworld.java, and I can open it by double-clicking on it. And I can even run this starter code by clicking this button here and selecting Run as Java Applet. You might have multiple choices there. If you do, just select Java Applet. I won't run it right now because I don't want to give away what it does. I'll let you wait until you start on the project to figure out what that does, but that's how you would run it. And then the other thing to notice is that there's this package called demos. And if you look at that, that's going to have a bunch of demos into our workspace directory. So just make sure that's checked. It has been successfully imported into our workspace. So you can see that now I have this starter code. If I expand it out, you can see that there's a whole bunch of files associated with this project. And if I open up the source code, I can see that it's divided into these organizational modules, basically called packages. So there's one package for every module that has a programming assignment. So module 1, 3, 4, 5, and 6. And that's where you'll find the starter code. So here we can see the starter code for module 1 in a file called helloworld.java. And I can open it by double-clicking on it. And I can even run this starter code by clicking this button here and selecting Run as Java Applet. You might have multiple choices there. If you do, just select Java Applet. I won't run it right now because I don't want to give away what it does. I'll let you wait until you start on the project to figure out what that does, but that's how you would run it. And then the other thing to notice is that there's this package called demos. And if you look at that, that's going to have a bunch of demos that we're going to be working with throughout the course in the videos. So if you want to run some of the code that we talk about in the videos, look here in this demos folder. We don't have all of it here, but we do have some of it. So you might find it here. All right, and so the last thing I want to tell you about is where to actually find all of these files on your file system. So remember when we checked that import into workspace button, that option when we imported the whole package? Well, what that did was it actually copied all of our files into our workspace. So if you go over here into our file finder, you can see that this folder here, UCSD Unfolding Maps, that's where we can find all of the actual files associated with our project. And you can see here in the source folder, and for example, module 1, this is where my actual .java file resides. But you'll be editing it through Eclipse. But if you want to know where it actually is, here it is. Okay, now you're all set up and ready to go, so have fun with the project.
The programming assignment for the first course module is really aimed at just getting us up to speed and running with unfolding maps. I know that many of you are eager to get programming, but before we can get there, you're going to have to get unfolding maps set up and running in Eclipse first. So please follow through our text and our video guides to help set up unfolding maps for your system, and then turn to the forums if you run into problems. But before we get there, what I want to show you is an example of a finished programming assignment for this first module. We'll give you the code to create the map on the left, which is centered on us here at UC San Diego. Specifically, we're really right about here. Notice that on this map, I'm able to zoom in and out. So zoomed out, I'm able to zoom in, I'm able to zoom in towards UC San Diego, and we're really right over here. Now, being able to zoom like this is pretty amazing. A lot of work goes into making something like that happen, including getting the map data from Google Maps to the handling of my mouse scrolling in and out. These amazing features are really just part of the libraries and unfolding maps and processing, which is why we're using these libraries for this project. All right, back to our assignment. We're going to give you the code to produce that image on the left, which is our map on the left, which is zoomed in to San Diego. What we want you to do is create the map on the right, which we zoomed in to where you live. Now, I live in San Diego these days, but I grew up in Pullman, Washington, which is on the east side of Washington State, and Washington State's on the west coast of the United States. So this is really just a small programming assignment just to get started with unfolding maps. The big step is really just getting unfolding maps and working on your system. So select the right video guide for installing unfolding maps, Java, and Eclipse on your personal system, and I'll see you again for the assignment walkthrough.
Okay, so now that you've learned how to create classes and objects, in this video we're going to show you a really powerful way of reasoning about your code and about the variables in your code that's called drawing memory models. So by the end of this video, you'll be able to draw memory models for variables that contain primitive type data like ints and doubles and floats, and you'll be able to update those memory models to reason about the values of those variables in your code as your code runs to try to figure out what is your code actually doing. Now, this is a really interactive lesson, so we want you to get out your pencil, get out your paper, and draw these memory models right along with us. Now, when I ask my students to get out pencil and paper in class, they kind of look at me like I'm crazy, like this is computer science. Why do I need a pencil and a piece of paper? And I actually usually walk around the room and say, hey, get out your pencil, get out your paper. Now, obviously I can't do that with you, but if it helps, imagine me kind of knocking on your door, knocking on your car window, asking you to get out your paper and your pencil to draw these memory models right along with us. It'll be a lot more interesting and you'll learn the concepts a lot better. So, to warm us up, let's look at this piece of code, and what I'd like you to do is just trace through this code and tell me what are the values of the variables var1 and var2 at the end of this code. In other words, what does this code print? All right, so if you got that example right, great job. This actually turns out to be a somewhat tricky example that a lot of people have trouble with. So if you did have a little trouble with it, don't worry, because what we're going to do now is we're going to use this example in order to illustrate this idea of drawing memory models so that you'll be able to get questions like this right forever, so for all of the future. And why is it important to be able to reason about code like this rather than just write code? Well, it turns out that people who are better at writing code are also better at reasoning about their code and vice versa. So practicing reasoning about code is a really important skill in order to become a better coder and software developer. So let's step through this code line by line and draw the memory model for this code as it runs. Let's start here on the first line. That first line is a variable declaration. What we're actually telling Java is, hey Java, I want some new space to store a value of type integer. And that space I'm going to label with the label var1. So in my memory model, what I'm going to do is I'm going to draw a box. That represents the space that I'm going to have to represent this variable, and label it with the name of the variable. So there we go, and you should do the same on your piece of paper. The next line of code here is an assignment statement. So what that's telling Java is, hey Java, take the value on the right-hand side, which in this case is 52, and place it into the variable on the left-hand side, which in this case is var1. So in our memory model, we'll take that 52 and we'll put it in the box for var1, which is where var1 stores its value. All right, next line. Another variable declaration. So we need another box labeled with the new variable name, which is var2. The next line is another assignment statement. Now this is slightly more complicated than the last assignment statement because the thing on the right-hand side is not just a number like 52. It's another variable. So what we need to do is we need to get the value out of var1 so we can then place that value into the variable var2. So we look in the box for var1, we see the value there is 52. So what we'll do is we'll copy that value over here into the variable var2. So now var1 and var2 both store the value 52. Now this is a really important point, that var1 and var2 are not the same variable. They're not tied together in any way. They just temporarily store the same value because this assignment statement told Java to take the value that's in var1 and put it into var2. But there's no connection between these two variables, which you can see in the memory model diagram. So now when we go on to the next line, which is another assignment statement, and take the value 127 and put it into var1, you will see that only the value of variable var1 will change. So I'll take that 127, replace the 52 that was already there, and the new value of var1 is 127. Now we're down here at the last line, which is this print statement, and all that's left to do is read the values out of those boxes for the variables. So when I print out var1 and var2, they'll have the values that you see in the boxes of 127 for var1 and 52 for var2, and this is what prints. So those are some simple memory models using just primitive type data, and in the next video we're going to show you how to get more complicated using objects.
what we get to do in this video is take the concepts that you talked about with Christine and apply them in an example so we can really work through them together and see how they help us step by step. So the key concept that we're going to be developing and thinking about here is that of memory models, and we're going to see how they apply for this code snippet that we'll trace through now. So let's think about what happens in the first line of code. First things first. And in this first line of code, we both have a variable being declared and then a value being assigned to that variable. So in our memory model, whenever we have a new variable, we want to denote that by writing the name of that variable and then drawing a box where we'll record the value of the variable. Okay, so we've drawn var1, we've drawn that in our memory model, we've got a box for it, and the value that's being assigned is the right-hand side of the equals over there, which is 17. And so we put that in the box. Cool. Now we can move on to the second line, and in the second line, well, we're declaring a new variable, so we have to update our memory model, which means that we need to write var2, our new variable that we just declared, and give it a box as well. And now we think about what goes into this box, and we look at the right-hand side of the assignment statement, and the right-hand side of the assignment statement says we want the value of var1 plus 1. But the value of var1 is recorded in our handy memory model right over here. It's 17. And so we add 1 to that, and the new value of var2 is 17 plus 1, which is 18. Cool. Okay. 2 lines done. We go into the next line, and the next line is now just a pure assignment statement. And what we want to remember is that for this assignment statement, we're taking the value on the right-hand side of the assignment statement, and what we'd like to do is assign that to be the new value of the variable on the left-hand side. Okay, so on the right-hand side over here, we've got var2 plus 1. And so we can look in our memory model for the current value of var2, which is 18. And so the value that's on the right-hand side here is 18 plus 1, or 19. So that's what's over here, this value. And what we do is we take this value and we copy it into the box for var1. So that means that var1's new value is that 19. Okay. And now we get to display our results. We get to display what we've done by printing out. So we've got the system.out.println command. And what we're writing here is var1 colon space, and then the value of var1, which we read off our memory model. And then we've got a comma, a space, var2. And then I'm running off the screen, but I'm going to put the next value right over here. And that's the value that we can read off of var2, 18. And we're done. Yay. So in this support video, we're going to take our work from the previous one. We've traced through some code, and right now what we'd like to do is test it and test our understanding. So by the end of this video, you'll be able to write testing code to verify the output of your trace of some Java code execution, and you'll be able to use Eclipse to run that code. So make sure that you've got Eclipse open and we can work together as we're developing the testing code. So we start with an example, and this is a piece of code that we used in the previous video, and we've used memory models to understand and to conjecture what's going to happen at the end of running this code. So doing that, if you think back to the previous video, you saw that we used memory models to expect that the system will print var1 colon 19 comma var2 colon 18. Okay, great. We've made this guess. We are pretty confident. We know how to use memory models, but we'd still like to check. And when we get to more complicated code that we've traced through, it's good to have another way of checking our understanding. And so a very good technique to doing so would be to put the code into a program that we can actually run. All right, so what that means is that our code needs to be in a class, because in Java, everything is in in classes. And so we can create a new file in Eclipse and call that file, for example, int assignment tester.java. Tester is indicating to ourselves that this is a testing class. And so we define a new class, public class int assignment tester. Remember that the class name has to match the file name. And then in the main method for that class, we stick the code that we want to test. Because when we run this class, when we run the code for this class, we know that the main method is going to be what's being executed. Okay, so we've defined this new file, we've put the code that we want to test into the main method, and now in Eclipse, we can run the code. And so remember that in order to run code in Eclipse, we have at least two choices. We can use the icon that has the white triangle and the green circle, or you can go into the Run menu and run the code in that way. And then in the window right underneath where we put in the code, we'll be able to see the output and be really happy because it matches what we expected.
All right, something I struggled with when I was learning computer science, and also I still really kind of struggle with it today, is just simply compiling and running and testing my code. I'm not really sure why, but when I started out programming, I was just terrified to compile and I was terrified to run because I was so afraid of the errors that were going to be in my code. And of course, we all have errors in our code, but it was a visceral fear. And I always thought, oh my God, like the computer's going to explode or something, and I would just not do it. So it would lead me to write these huge methods and these huge programs before I compiled or ran anything. And it was a big mistake. So I got over that just by kind of practicing more, hitting that compile button and the run button, and realizing that nothing happens. Your code breaks and you fix it, and it's not a big deal. So that's what I've learned. But it's still kind of scary for me sometimes. So in the last video, we drew memory models using only primitive type data. In our case, last time it was integers. But this time we're going to add objects into our memory models. So our goals for this video are the same basically as the last time, only this time you'll be able to draw memory models using object type data and primitive type data, and reason about code that uses both primitives and objects. So before we begin, let's just give an example of the two different types of data. You're probably already familiar with this from your earlier courses in Java, or courses in Java. The Java has two fundamentally different kinds of data. It has primitive kinds of data, which consist of only 8 types. So Boolean, byte, short, int, long, float, double, and char. Those are the 8 primitive types of data in Java. Everything else is an object, whether it's an array or a user-defined class or a class that you find in a library. Everything else is an object. So obviously learning how to add objects into our memory models is going to be really important for reasoning about code. So here's a short snippet of code right there, just 2 lines that show an example of both a primitive type, the integer, and an object type, which is our class simple location, which we defined in the last lesson. We're going to reason through a short snippet of code that combines both integers, primitives, and these objects of type simple location. We're going to step through this code the same way we did in the last video and draw the memory model as we go. So to get things started, we've got a nice, easy variable declaration and assignment statement. And you already know how to handle this one. This is just an integer, just like we looked at before, var1. We create a box, we put the value of the variable in the box. In this case, it's 52. So that was easy, no problem. Let's go on to the next line. The next line turns out is pretty easy as well. All it is a variable declaration. So we handle this in the same way, regardless of the fact that it's actually an object type variable. That doesn't matter for our variable declaration. So we're going to make a box and label it with the variable's name. There it is. It's this next line where things get interesting. This is an assignment statement. And what we're doing is we're creating a new instance or a new object of type simple location, and then we're setting the value UCSD equal to whatever happens when we create that new object. So now to understand what's going on here and how it's going to affect our memory model, we need to look a little more closely at what happens when we create a new object in Java and what's going on in your computer's memory. So when we say new simple location, what Java's doing is it's creating a new object, which means it's allocating some space in your computer's memory to store that object. So let's take a closer look. What it's doing is creating that object, which is allocating some space, and it's doing that in a part of your computer's memory called the heap. So it creates that new object in the heap, and then what it does is it puts that object at some location in the heap that has some address. It's not necessarily, we don't know where Java chooses to create that object, so we'll just represent that address where Java creates that object with this little @34. So that object is at location 34. That's just a random number that I picked off the top of my head. It's wherever Java happened to create that object in the heap. So now what happens is, when we've created that new object and Java creates it at location 34, what it actually does is it doesn't place the whole object inside the box for UCSD. It places a reference to that object in the box for UCSD. In other words, it places the location of the object, wherever it's stored in the heap, into the box for UCSD, and that's called a reference. So now I said 34 is just kind of a made-up number. I don't necessarily know that this simple location object exists at the location 34. So typically in my memory model diagrams, rather than making up arbitrary locations for all of my objects, what I'm going to do is I'm going to draw an arrow from the box for the variable UCSD to the object that's created in the heap. But remember that this arrow really just represents this reference, this number that represents the address, or something like an address, of where to find this newly created object in the heap. So it's actually a number in the box, but that number effectively represents the location of the object in memory, so we draw an arrow from the box to that location in memory. And that arrow is actually the value of the variable UCSD. All right, so now we've got our new object. We've got the value of UCSD, which is a reference to that newly created object in memory. Now let's look a little bit closer at what that object looks like over there in memory. So this class simple location has two member variables, and both of these member variables are stored inside the object. So we can open up that object, look inside, and we can see that inside we actually have two variable declarations. There's latitude and longitude. So we're going to draw boxes just like we did before with that integer var1. We'll create a box for latitude and a box for longitude and label them both with their names. Those boxes are going to store the values of latitude and longitude when that object is created. And where do they get their values? Well, they get them from the constructor. Those values that get passed in are the values that go into the latitude and longitude variables inside that object, which is over there in the heap. So this is the complete memory model after these first three lines of code. We've got our primitive variable var1 storing the value 52. We've got our object type variable UCSD, which stores a reference, which is essentially just a number representing the location of this newly created object in memory, which we represent in our memory model diagram as an arrow. And then we have our object, which has two variables inside of it, latitude and longitude. The next line down creates another new variable, and it creates another new object. And then we'll create a link between the two by storing the reference to the new object in the new variable. So let's take that down piece by piece. In order to draw this part of the memory model, what you would do is you would handle the declaration first, draw that box, label it with the variable's name, which is Lima, draw the new object over here in memory, put the two member variables that are inside that object as boxes labeled with their names inside the object, and then link the variable Lima to the newly created object by placing a reference inside the box for Lima, which again is the value of the variable Lima. All right, so we're almost there. This is the last line. Let's look at this last line of code, which actually changes the value of latitude inside the variable Lima. So let's say, for example, we want to tweak the value of the latitude variable, make it a little more precise. What happens in our memory model when we make this change to the variable latitude inside the object Lima? Well, what Java says when it sees a statement like this, lima.latitude, what that means is
it wants us to follow the arrow from Lima into memory to the object it finds there and find the variable latitude inside that object. So that's how that we know. We're not talking about latitude up there in the UCSD object. We're talking about latitude down in the Lima object because we say Lima dot latitude. So we go to the box for Lima, we follow the arrow, and then look in that object to find the variable latitude. We find it, and that's where that value, negative 12.04, is going to go. So we change the value of the variable latitude inside that object, and that's all there is for this code. And here we have the final memory model representing the state of all the variables and all the memory in this code when the code is finished running. So now that you've mastered these memory models, you should be able to reason about lots of different examples involving both primitive variables and object type variables. So we've got a sequence of challenges and practice videos for you to try out your new skills.
Welcome back. Welcome back. We're going to do a challenge question at this point. So you've learned a great deal about memory models, but let's see if we really understand it well. What we're going to do in this video is we're going to walk through two questions, the first of which will just be a question where we stop and come back, and the second question is where we're actually going to walk through the full concept challenge procedure. Again, the procedure is you're going to pause, think about the problem, solve it yourself, discuss it potentially with other learners, watch a video of UCSD learners discussing it, and then confirm your understanding with our explanation. So first, to get things started, what I want to give you is an example piece of code. So I have the simple location class that we've already been working with, and then I'm just going to create in main an example of one of those objects. So what I want you to do is pull out your pencils and paper, pause, draw the memory model as it stands right now, and then come back. So if this was the model that you drew, you're spot on. And this gives us a good starting point now for our next question. So we're going to scale the question a bit. We've got a single variable now within main. We've also got two objects that we're creating within main. The question here is, what memory model is going to result? Again, pull out a piece of paper and a pencil, draw this yourself, and then we'll come back together.
Hi, my name is Hazil.
Hi, I'm Julia. And I'm Monica. And let's just get started. Okay, so far, looking at this, I noticed that there are two objects. So we can immediately cross out C.
So how are there two objects?
They both are simple location objects, so wouldn't they point to like a simple location inside the heap? Yeah, but each one is a new simple location, so they don't point to the same area in the heap. They point to different areas because they're both new objects. So Washington, D.C. gets its own place? Washington, D.C. gets its own place.
So there are two objects because there's two news, right?
Right, there's two news.
So that means C is not the answer.
Yeah, that's what I thought.
Okay.
But the part where I got a bit confused on was when I tried to look at each of the different locations in memory. And I understand why latitude is -12 for each one of these, but I don't really get why D doesn't point to -77, or whether it actually is just -77 in the box.
So we know that D is primitive, which means that it's just a constant number.
Right.
So primitive types, which are constant numbers, do not need an arrow. That's what I think.
Oh, why don't we need an arrow though? I mean, it's inside the object's memory area.
But the item itself is not an object.
Oh, okay, I see. So then you just write it directly into the box for both cases?
All right, now that you've heard an explanation about this from our UCSD learners, you're already seeing how this works. And really the only way to do this is to trace the code just as they did. And I'm going to do that for us here. We're going to start at the very top of main, as we always do, and we're going to have a single double variable D that's assigned the value -77. And you can see that's within the scope of main in the drawing below. Then I'm going to create a reference for Lima. And just like we did at the very start here, is I'm going to actually now create this object. So when I call new simple location, that allocates space on the heap. You can see that on the right. And then I'm going to pass in as parameters -12 and -77. That's the value of D at the time that it's passed in as a parameter. Perfect. All right, now we can do the second piece. Now we're going to create a second object, we're creating a reference for a second object, which is called washdc. And now I'm actually going to create the object by calling that new simple location. So again, new simple location allocates space in the heap for a new object. And I'm now going to call this method passing in these two parameters. And the key part to this problem is really what happens with lima.long. When you call a constructor and you're passing these values as parameters in Java are always passed by value. So 38.9 is going to be copied over as exactly 38.9. And lima.long is going to be evaluated to be the -77 that it is. And then that -77 is what's passed for long in. Now we're going to copy the values over just like we did before. We're going to copy into this.lat. We're going to copy into this.long. And then at the very end of this constructor, we're going to hook up washdc to that lat and that long, or that object that contains the lat and the long. So this is our memory model at this point. Was this close to what you got? I hope it was. If it wasn't, it's worthwhile walking through a couple more of these memory model problems. Keep in mind that when you're drawing memory models, the purpose of this is to really understand your code. It's difficult to reason and debug code if you're not drawing the memory model associated with it. As we continue working through this module, it's important that we have these concept challenges. So the reason we're doing these again is that it's important to test your own understanding. So you can listen to us talk about the material, but until you've really tried to apply it, you don't know for sure whether or not you're understanding it correctly. So this is an opportunity for you to identify potential misconceptions in your understanding, or to gain confidence in the fact that you're understanding it properly. The process again, we're going to pause, you're going to try to solve it yourself, you're going to discuss it with potentially other learners around you, you're going to watch UCSD learners talk about the concepts, and then you're going to confirm your understanding with our explanation. So the problem for this one is to walk through this code, again, always start executing in main, and at the very end of main, there's going to be a print. And the question is, what gets printed?
Hi, I'm Tanky.
Hi, I'm Peter.
Hi, I'm Joe.
All right, so let's go ahead and get started. So I guess we can all agree. So location 1 is going to create a new simple location with those values, and location 2 is going to create another simple location with those values as well.
And we're talking about objects right here?
Yeah. So we're going to have two different objects, location 1 and location 2.
Mm-hmm.
What I got stuck at was when location 1 equals location 2. So what I was thinking was that the values inside location 2 are actually going to copy over into location 1.
Oh, like a whole new object?
Well, not exactly a whole new object, but just the values of the latitude and longitude into location 1. So currently,
like rewrite.
Yeah. So currently
the object.
location 1 has 39.9, for the latitude, and well, I was thinking that location 2's latitude 55.8 would overwrite that. Am I right? Or
I think those are like two objects, right? Like they are separate. So I think the third line is just change the reference here, so it won't like override like the every like member variable here.
So like rewrite the arrow instead, like where location 1 is pointing.
Right.
all right, so location 1's now gonna reference to the same object that location 2 is referencing,
And
right?
you just follow the arrow.
All right, okay. So that means that location 1's values do change, but it's just because it's referencing a new object.
Correct.
Yeah.
Yeah.
All right. So when location 1 dot lat gets negative 8.3, that means that the latitude of location 1 changes to negative 8.3. But since that's the same object referenced by location 2, does that mean location 2's latitude changes to negative 8.3?
Yeah, I think so.
Yeah, because it's all just one
Yeah, you
object.
just
That was a great discussion by the UCSC learners. Let's walk through the code again one more time. So you're going to start in main, you're going to create a simple location reference, loc1, that's going to point to an object. And we just did those memory models, so we'll do this one a little bit more quickly. We're going to recognize that this is going to create a reference loc1 pointing to an object on the heap which has these values. We're then going to create a second object. This one's going to be loc2, and loc2 is pointing to a different object on the heap. The key part of this problem is what happens in this next statement. What happens when you assign loc1 to be equal to loc2? What really happens there? To understand that, we're going to have to think about what those references really mean. So loc2 points to this object, and what that really means is that loc2 has a numeric value, which is an address for that object on the heap, and that object on the heap actually has that address. So you can think of loc1, we're throwing in arbitrary addresses here, but loc1 has address 1, it points to that object on the heap. Loc2 has address 2, and it's pointing to that object on the heap. When you do loc1 equals loc2, you're really copying essentially the reference. What that means is you're copying the address. So loc1 is now going to point to the exact same thing that loc2 does. Now, when we do loc1.lat equals this negative value, you're going to realize loc1 points to the same thing that loc2 points to, and it's going to change that object pointed to by loc1. Then we're going to go to print this. We're going to print using the loc2 reference, but again, loc2 and loc1 are pointing to the exact same thing on the heap. So when loc2 prints out its lat and long, it's going to print out minus 8.3 and 37.6. Again, drawing these memory models helps you understand how to work through these problems.
In this support video, we'll be practicing two really important skills. First, we'll be tracing code using the memory models that we've been talking about before for both object and primitive data. Pointed to the same object with the latitude and longitude variables set as we did when we constructed the Kumamoto object. In this support video, we'll be practicing two really important skills. First, we'll be tracing code using the memory models that we've been talking about before for both object and primitive data, but we'll also be developing a skill of tracing code and talking about it in high-level terms beyond step-by-step what each statement does. Now, you want to make sure that you're ready to participate, get a pencil out, and work with me through this. You'll learn much better if you're working through it yourself as well. So let's start with a piece of code that we'll be thinking about and take a few seconds to read it carefully and try to explain in your own words what this piece of code does. All right, welcome back. It's very useful to try to think about how the code and the syntax that we have in Java translate to steps and procedures that we can understand as high-level human beings. So for example, if we're thinking about this in words, what we might say is that we create a couple of objects and then we try to assign those objects to one another. When we say assign objects to one another, that's very imprecise. And so this gives us an added perspective on the benefit of tracing code and on the benefit of the precision that comes with memory models. All right, so let's see what we do when we trace the code. We remember that in order to declare simple location type objects, what we need is to think about the simple location class, and we're using the class definition that you've seen in the core videos for this module. So you'll be fairly familiar with this definition, but you can look at it here as well. The first line of code that we have is a declaration and an assignment statement. We're reserving some space in memory. We're labeling it UCSD, and what we would like to have there is a reference to a new object. That new object is of type simple location, and it's initialized using the constructor to some values. So what that means is we have a box in our memory model. It's labeled by the name of the variable UCSD, and we point to this new object that we've created whose instance variables latitude and longitude are set to 32.9 and negative 117.2 respectively. And that's all there is to that first line. So now we go on to the next line, and that next line has exactly the same form. We're declaring a variable. That variable is of type simple location. And so we have a reference to a new object. That object is being created by the constructor, and those instance variables have their own values. And notice that those instance variables for this new object are completely separate from the variables that we had for the previous object. We've constructed completely new copies of these objects. All right, now we get to the third line, and in this third line, we're not creating any new objects. We're not declaring any new variables. What we're doing is we're doing an assignment statement. And an assignment statement, what we would like to do is to assign the value on the right-hand side to the variable on the left-hand side. And so let's think a little bit more about what's actually stored inside these variables. So UCSD, that box in our memory model, has an arrow to an object, but remember that arrow to the object is our visual shorthand for saying we have stored the address in memory of that object. So something like at 15. 15 is a made-up number here. It's to indicate some address, the address of the object that we created before. Similarly, the box associated with the variable Kumamoto stores an address, which is the address, the reference to a new object of type simple location. So it's got a different address because we've got two different objects. Now what we need to do in this assignment statement is we need to copy the contents of the box Kumamoto to the box UCSD. And so that means that the at 34 reference gets copied into the UCSD box. And so if we think about that in terms of our memory model, what's happening here is that now both of these variables refer to the same object, the object of the address at 34. Okay, so that's what we've done with this assignment statement. But now what happens when we go to the last statement in this code snippet? Here what we're trying to do is we're trying to assign the value that's stored in the variable UCSD to the variable Kumamoto. But if we look at that value that's stored at the variable UCSD, it's the address of the object that we had before that was also pointed to by Kumamoto. So actually executing this assignment does nothing at all. It's saying copy at 34 to Kumamoto, and that was the previous value of Kumamoto before as well. So at the end of executing this line of code, if we were to test it using the strategy we talked about before by throwing it into a class and execute it into the main method of a class and then running that piece of code, then we see that both UCSD and Kumamoto, both of those variables pointed to the same object with the latitude and longitude variables set as we did when we constructed the Kumamoto object.
Okay.
Disconnect